Hello, welcome to Engineering Nebraska Structural Engineering Tutorials. So ngayon, papag-aralan natin ang seismic detailing of special moment frames, RC column, as per NSCP 2015 Section 418. So ano-ano nga ba yung mga code provisions o mga detailing na dapat nating malaman as a practicing structural engineering sa para maging earthquake resistant yung ating column. This is under NSCP 2015 Section 418. So, let's start. So, meron tayong dimensional limits. So, columns shall satisfy A and B. So, tingnan natin. The shortest cross-sectional dimension measured on a straight line passing through a geometric centroid shall be at least 300 mm. So, yun nga. Dapat ang shortest dimension ng ating column to be earthquake resistant or to be passing dun sa seismic detailing shall be at least 300 mm. Then, the ratio of the shortest cross-sectional dimension to the perpendicular dimension shall be at least 0.4. So, the ratio of the smallest to the largest cross-sectional dimension shall be at least 0.4. So, next. The longitudinal reinforcement. So, according to NSCP Section 418, NSCP 2015, area of longitudinal reinforcement, AST, shall be at least 0.01 Ag and shall not exceed 0.06 Ag. So, ibig sabihin, 1% to 6% lang ng cross-sectional area ang longitudinal reinforcement. Then, in columns with circular hoops, mga babilog, there shall be at least 6 longitudinal bars. So, dapat a minimum of 6 longitudinal bars for a column with circular hoops. Ngayon, so okay, papag-aralan natin ang transverse reinforcement. Ayun yung mga tawag dito mga ties, hoops, ganyan. So ba't nga ba natin kailangan ang transverse reinforcement? So bakit ba siya? Ano ba ang importance niya? So, number 1, this is the list na nakita ko para yung mga importance ng transverse reinforcement. So, number 1 is to confine the core concrete. So, ano ibig sabihin yan? For example, meron tayong pick-up sticks. So, let's consider a pick-up sticks and this pick-up sticks is our concrete. Ngayon, ang ating ties or circular or ating hoops o mga hooks ay magko-confine sa core concrete natin. So example, i-try mo yung pick-up sticks, i-close mo siya ng iyong fist, then try to load it. Compare mo siya dun sa walang confine na concrete. Anong mas malakas? Tama 'di ba na kapag kinonfine mo by your fist yung pick-up sticks, mas malakas yung force na may apply mo sa kanya. So ganyan din sa circle, sa mga column natin. So this is our column and ito yung concrete core sa loob. Next, to provide lateral support to longitudinal reinforcement. So anong ibig sabihin yan? Magpro-provide daw siya ng support dun sa ating longitudinal reinforcement, yung mga pahabaang reinforcement. Magbigay siya ng lateral support. So for example, this is our cross-sectional lang column. Ito yung concrete, ditong side yung concrete, ito yung transverse reinforcement, and this is the longitudinal reinforcement. So this is the longitudinal reinforcement. So, ano bang ibig sabihin yan? Magpo-provide siya ng lateral support. So, for example, meron tayong lateral force na tumutulak, and this is our longitudinal reinforcement. So, when a lateral force is applied, tama ba na kapag may longitudinal reinforcement siya, ganyan siya magbabakel, di ba? So, hino-hold niya yung longitudinal force together when deflected due to the lateral force. So, parang sama-sama silang magde-deflect. Compared mo kapag tinanggalan mo siya ng transverse reinforcement at tinulak mo siya, para lang siyang stick na madaling itulak pa palaterally. Tama? So, nagpo-provide siya ng lateral support sa longitudinal reinforcement. Sama-sama sila, kumbaga, kung magde-deflect man yung isang longitudinal reinforcement, magpo-provide siya ng ng support due to the transverse reinforcement. So, next is to confine the longitudinal reinforcement lap splices. So, ano ba yung lap splices na yan? Diba? Kapag hindi, for example, ang building mo is nasa 10 stories, then, diba, ang nabibili lang sa construction is approximately mga 12 meters yung, diba, yung 6 meters, 12 meters yung steel bar. So, kailangan mo siyang idugtong. So, kailangan mo mag-lap splice. So, yung area ng lap splices, kailangan mong suportahan yon. So, parang to support the lap splices para maprotektahan yung weak part. Kasi kapag naka-lap splice yan, medyo weaker area yan eh. Kasi parang dinugtong mo siya, di ba? So, to confine the longitudinal reinforcement lap splices. And lastly, to provide shear strength. So, ito, alam natin na ang transverse reinforcement is magpo-provide ng shear strength sa ating column, just like the beam. For example, this is our column, then the maximum moment will most likely, the large moment most likely will produce as it ends. So, dun sa may dulong part. So, magpo-create ng mga plastic hinges dyan, di ba? So, yung lateral, yung transverse reinforcement is to provide mag-shear strength. So, this is our column shear. So, magpo-provide niya ng shear strength yung dun sa may, sa may ends ng column natin. So, to protect. So, pag-aralan natin yung mga column reinforcement zones. Yung mga, yung mga lugar or yung mga zoning dun sa ating column. For example, this is our column. So, ang tawag dito sa may reinforcement dun banda sa may beam and column connection or beam column joint, ang tawag sa kanila ay joint tie zones. And dito naman sa LO distance, dito yung confinement tie zone. Dito kasi, di ba, alam natin na malakas ang moment dun sa may dulong end part ng column and magkikreate ng mga plastic hinges dyan. So, dun mas masinsin yung pag-aano ng bakal. Dun mas smaller spaces yung mga reinforcement. So, ang tawag sa kanila is confinement tie zone. Then, yung beyond the confinement tie zone, ang tawag sa kanila is tie zone. Then, ngayon, pag yung mga splice, ito naman yung splice zone. Ang splice zone ay pwede ka lang mag-splice within the center half of the member length. So, center half of the member length. So, ibig sabihin, sukat ka ng 1/4 ng LU sa top and 1/4 ng LU sa bot. Then, yung natitira, yun yung splice zone. Doon ka lang pwedeng mag-splice. Diba? Bakit ba nag-i-splice sa gitna? Kasi diba mas maliit ang moment sa gitna. Mas malakas ang moment doon sa dulo. Sa may ends, diba? End part. Then yung LU natin is yun yung clear to clear. Clear span between the column. So beam, yung end ng beam na to, tsaka yung beam na to. So yun yung clear span ng so this is our column reinforcement zone. So joint tie zone, confinement tie zones, and the splice zones. So pag-aralan natin, what is the length of our confinement tie zone? Yung LO na yon, ano ba yung distance nun? So kino-compute yon. So this is our LO, the confinement tie zone na tinatawag. So the confinement tie zone based on NSCP section 418, the confinement tie zone shall be found in LO maximum of the following. So, ito yung mga following. Sa HC1, ito, yung cross-sectional dimension nito, largest cross-sectional dimension ng top. And HC2, or the largest cross-sectional dito, sa baba. column. Kasi pwedeng mangyari na magkaiba yung size ng column na to. Tama? Size ng column sa baba at sa taas. Pinaliitan nila, pwedeng mangyari yon. So, next is the 1/6 of the clear height. So, LU over 6, 1/6 ng clear height. And last is the 18 inches or 460 mm. So, pipili ka lang ng maximum neto, maximum governs, di ba? Then, dapat nandun yung confinement tie zone mo. Doon ka lang, doon yung mga masinsin ang spacing mo. Doon yung mahalaga. Kasi yun yung pinakamahalagang zones dito sa zone sa column reinforcement. Itong confinement tie zones. So, ulit, HC1 or the largest cross-sectional dimension, and 1/6 of the clear height, 18 inches or 460 mm. So, ano ba yung spacing requirements S1 along the confinement zone? So, yung sa confinement zone, ano ba yung mga spacing requirements? So, based on NSCP section 418, S1 shall be less than or equal to the following. So, minimum of HC1 over 4. So, yung 1/4 of the least dimension ng taas and sa baba. Least dimension take note, 1/4 of the least dimensions. 6 dB or the 6 times diameter of the smallest longitudinal bars. Pwedeng mangyari kasi na iba-iba yung longitudinal bars na ginamit. So, pwedeng mangyari yon. So, ang kukunin mo is yung 6 times the smallest longitudinal bars. Then, yung SO, mamaya pag-aralan natin yan, take note na term na SO, S sub O, or S naught, as per required for transverse reinforcement of special moment frame and as required for shear. So maximum spacing of transverse reinforcement along LO. So, yung maximum spacing na yan, ito yung first three. First three dito sa given na to. Itong first three. So, yun yung maximum spacing of transverse reinforcement along the confinement tie zone. So, ito yung 1/4 least dimension, least column dimension, tama? Then, the 6 dB of the smallest longitudinal bars. And S naught, ito yung 100 plus 350 minus HX all over 3 in mm. Pero, dapat hindi siya bumaba sa 100 mm or less or tumaas sa 150 mm. Take note of that. So, S naught is 100 plus 350 minus HX all over 3. Greater than or equal to 100 mm, but less than or equal to 150 mm. Or sa in English, 4 inches and 6 inches. So, ang formula naman doon is 4 plus 14 minus HX all over 3. So, ano ba yung HX na yan? So, ang HX natin is the maximum center-to-center spacing of hoop or the cross tie. So, for example, this is our column. So, ang HX dyan, tama ba? Sabi niya is maximum center-to-center spacing of hoop. So, ito siya. Either pabalagbag or yung patayo. Diba? So, yung green HX or yung red HX na yan. Tama? So, paano ba kinocompute yung HX na yan? Yung maximum center-to-center spacing. So, ito yung mga tip ko para makompute nyo yung HX na yan. So, kukunin mo lang yung pinakamalaking HX dyan sa lahat ng nakikita mo. So, based on my, tinginan lang, or quick observation na itong dalawang to, yung malaki sa pahiga at sa pataas. Tama, di ba? So, how to find HX? So, establish natin yung paano mag-solve ng HX. So, ang gagawin mo, first establish the XI. Ito, yung naka-note na yan, yung XI na yan. What is XI? It is the center-to-center spacing of longitudinal bars. So, paano mo ma-establish yan? So, establish ka muna ng XI. So, para ma-solve yan, so yung dimension D, for example, this one. So, for example, this one, this is D. For example, this is D. Then, D minus 2 size ng concrete cover, di ba? This one and this one. So, ang minimum concrete cover natin, let's say 40 mm, minus 2 diameter of ties, di ba? may tie dyan, may tie dyan. So, 2 diameter of ties minus dalawang beses na 2 times dB over 2 or the bar over 2 para ma-establish mo yung distance na to. Tama? Establish mo yung total distance na to. Then, divided by the number of longitudinal bars minus 1. So, for example, this is 1, 2, 3, 4, 5 minus 1. So, 4. Tama na meron kang 4 xi dito. So, makaka-establish ka ng xi. So, next, pwede mo nang makuha yung hx. So, paano gawin yan? So, for example, this red, yung green hx na to, tama? So, xi mo lang plus dalawang dB over 2. So, punta ka dyan, dB over 2, then dito, dB over 2 din, or 1/2 the longitudinal bars, plus dalawang diameter ng ties over 2. Kasi center to center spacing. So, center dyan, then center dyan. So, makaka-establish ka na ng hx. Tama? So, yun lang. Establish xi, then center to center spacing of longitudinal bars, then rekta ka na sa hx. So, the spacing requirements SO along confinement zone LO naman. So, sinabi doon na as per required, doon sa nakalagay na table, di ba? Meron pang, ito yung required. Itong tatlo na to, is sila yung maximum, yung, this one. This is the maximum spacing of transverse reinforcement along the confinement zone. So, this is the maximum. So, ang required naman natin dyan, this one is naka-table. So, the spacing requirement. So, given na may conditions ka, take note of these conditions kasi these conditions will tell you anong formula ang gagamitin mo. So, condition 1, dapat masatisfy itong dalawa. Dapat masatisfy kasi gamit ng term na end. So, dapat masatisfy ito. So, if PU or the ultimate axial load is less than or equal to 0.3 ng AG and FC prime, and FC prime is less than 10,000 PSI or 70 megapascal, so ang consider mong formula is letter A and letter B. Si letter A and si letter B. So, maximum of the two. So, largest governs yan, di ba? But, kailangan mong i-check siya dun sa maximum spacing na nakalagay kanina. So, take note ko lang yung mga term. S is the spacing. Ito yung hinahanap natin. BC is the base of concrete core. So, AC is the area of concrete core. This ACH is the area of concrete core. ASH is the area of transverse reinforcement parallel to shear action. So, parallel to shear action, then yung BC naman is the perpendicular to shear action. Kailangan mong tandaan yan. Yung mga yan. So, let's try to, for example, meron tayong shear force Vx. So, meron tayong shear force Vx along the x-axis, di ba? Meron siyang applied shear force. So, the ASH is the, kailangan, ang ASH is parallel to shear action, di ba? So, parallel to shear action. So, parallel to shear action, this is Vx, so parallel to shear action. So, ilang area of ties ba ang nagpaparallel sa shear action? Tama ba na 4? 4 na ties. This one, this one, and tsaka this one. So, ang area of transverse reinforcement along parallel to shear action is 4 times area of ties. Tama? Then, the base of concrete or BC is the dimension minus 2cc. So, this one is the base of concrete mo. This base of concrete core, this one. Okay. So this one is your base of concrete. Base of concrete core. So this is another dimension. So BC2, dimension minus 2, concrete cover lang. Ang core natin, tandaan nyo, is minus 2cc lang. Minus 2 times concrete cover. So, ang AC natin or ACH is the area of concrete core. So, rectangle siya, area of rectangle. So, BC1 times BC2 lang. So, ito yung mga term na kailangan nating malaman. So, kapag shear force Vy naman, so, ganun lang din. Yung ASH mo, yung area of transverse reinforcement mo, is parallel. So, dito naman, pahiga naman siya. Tama? Then, yung BC mo, BC1 mo is BC2 na. So, in equation C, nakita nyo sa equation C, meron siyang term na KF and KN. So, di ba? Kita nyo dito sa this one, meron siyang factor na KF and KN. So ASH over SBC shall be greater than or equal to 0.2 KF KN PU over FY ng ties times area of concrete core. So, ano ba yung KF and KN na yan? So, ang KF and KN na yan is the concrete strength factor and the confinement effectiveness factor. So, yung concrete strength factor is given na formula na F prime C over 175 plus 0.6 shall be greater than or equal to 1.0. Kailangan ang mataas sa 1.0 unless kapag mababa, adopt 1.0. So, F prime C is the compressive strength at 28 days. Compressive strength of concrete at 28 days. Next is the confinement effectiveness factor. So, NL over NL minus 2. What is NL? So, the number of longitudinal bars or bar bundles around the perimeter of a column core that are laterally supported by the hoops or the seismic hoops. So, for example, this is our column again. Then, the NL dyan is 14. So, why 14? So, around the perimeter, then, bilangan mo yung longitudinal bars na may laterally supported. Tama na. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Tama? So, meron tayong 14 NL. So, KN lang is 14 minus 2. So, 14 over 12. Now, based on NSCP Section 418, in-adapt siya galing sa ACI 318. So, alam naman natin na adapted yung NSCP 2015 sa ACI sa concrete sa chapter 4 natin, di ba? So, ngayon, meron silang special provisions given these two considerations. Yung PU is less than 0.3 FC prime AG and FC prime na less than or equal to 10,000 PSI. Ito yung case 1. Then this is the case 2 of P if ultimate actual load is greater than 0.3 FC prime AG or FC prime greater than 10,000 PSI or 70 megapascal. So, state that every corner and alternate longitudinal bars shall have at least support and no bar shall be farther than 6 inches. So, from laterally supported bars. So, given a case 1, kailangan daw yung longitudinal bars natin is dapat at least may lateral support alternate. So, for example, this one. So, pwede mong alternate yung this one. Yung itong longitudinal bars na to, yung kasunod niya walang seismic hoops, di ba? Yung sumunod niya meron. So, yung sumunod wala, sumunod meron, sumunod wala, sumunod meron. So, every corner, alternate longitudinal bar shall have lateral support, at least. Then, kailangan, yung no bar shall be farther than 6 inches. So, kailangan yung, this one, itong bar na to, yung XI na to, XI na to, kailangan, ang minimum niyan is, shall be farther than 6 inches. Dapat hindi lumagpas ng 150 mm yung distance na to. This one, yung distance ng longitudinal bars na may lateral support. And then, or this one and this one. Then, consecutive cross ties around the perimeter and along the length have 90 degrees hoop on the opposite side of the column. So, yun nga, sinabi na. So, this one is my 90-degree hoop. This is 135-degree hoop. So, kailangan sa opposite side, alternatively din sila. So, meron kang 90-degree hook on the opposite sides of the column. So, yung hook, ano na yan, is based on 6 dB or greater than or equal to 3 inches or 150 mm. Then, meron din 6 dB extension kapag naka 90-degree hook, di ba? Based on development length. So, the dimension xi, this yung kasasabi ko nga, dimension xi from the center line to center line of the supported bar shall not exceed 14 inches or 360 mm. So, yun, shall not exceed 14 inches or 360 mm. So, bawal lumagpas ng 360 mm. So, meron siyang dalawang limit, 150 mm and 360 mm. So, yung case 2, every longitudinal bar around the perimeter of the column shall have lateral support. So, dapat may lateral support provided that the hoop, corner hoop or by seismic hoop. So, yan. Kapag case 2, if PU, sobrang laki na niyan, 10,000 PSI yung gamit, or, tandaan na, or, at least one lang yung at least one lang yung nasatisfy. So, kapag nasatisfy yung PU, ultimate axial load is greater than 0.3 FC prime AG or FC prime is greater than 10,000 PSI. So, yon. So, kailangan every longitudinal burst daw is meron siyang hoops or 6 may lateral support. So, the dimension xi naman dito shall not exceed 8 inches or 200 mm. Bawal lumagpas ng 200 mm. Diba? Yun lang. This is additional provisions. So, punta naman tayo sa spacing requirement S2 beyond the confinement zone. So, away from the confinement zone. Ano naman yung spacing requirement beyond the confinement zones? So, the beyond the length LO, the column must have hoops with spacing not exceeding the smaller of 6 dB, 6 inches, and as required for shear. So, ano ba yung S2? This one. S2, this one, shall be the smaller. So, smallest govern yan, di ba? Sa 6 dB, 6 inches, or as required for shear. So, the exception is where the column or the longitudinal reinforcement is splices. Dito sa may lap splice na to. In which case, hoops along the lap splices are required to satisfy the same requirement as specified for the length LO. So, ibig sabihin, the spacing in the tension zone or tension lap splice zone is same requirement as specified in the confinement tie zone. Yung sa spacing in the confinement tie zone. So, ibig sabihin, the spacing in the splice zone is equal to the spacing or same requirement as to the spacing in the confinement tie zones. So, along the splice zone, use the governing S1 or sometimes in actual, they use 100 mm on center spacing. So, during the splicing, doon sa splice zone, gumagamit na sila ng 100 mm spacing na lang para mas masinsin na spacing. Yun yung limit doon sa S1 di ba? Tandaan nyo na ang limit sa S1 is 100 mm. So, punta tayo doon sa splicing of columns. So, the lap length with a slope of 1:6. Dapat, ang pag-splice natin ay naka-slope. Hindi siya dapat ganito. Kasi kung ganyan yung picture mo sa splicing mo sa picture 1, tama na, every splice mo is lumiliit yung size ng column mo, which is wrong. Kailangan monolithic yung column mo. Or dapat parehas yung sukat, di ba? So, kapag ganyan ang ginawa mo, Mahina yan, tama? Or nagbabago, every time na mag-splice ka, lumiliit yung size ng column mo, which is wrong. Kailangan magroon siya ng slope na 1:6, like this one. Then, the distance of lap length shall be accordance to the parameters for the development length. So yung distance nito is according to the development length. So, tension lap splices. So the distance between the splices shall bound within the splice zone shall be 600 mm from end to end. So, yun nga, kailangan pala na yung distance ng splice zone mo, this one to this one is at least 600 mm. So hindi ka pala basta-basta mag-i-splice lang. Tingnan nyo to, may mga distance sila sa splices nila, di ba? So, additional requirement in hoop configuration. So, column hoops shall be configured with at least 3 hoops or cross-tie legs restraining longitudinal bars along each face. So, a single perimeter hoop without cross-ties, although permitted by the ACI 318, for column cross-section is discouraged because confinement effectiveness is low. So, for example, this is a column hoop configuration. The picture 1 is poorly confined. Picture 2 is improved confinement, and picture 3 is the well confined. So, based on ACI 318, it stated that the column hoop shall be configured with at least 3 hoop or cross-tie legs. Kailangan meron tayong 3 hoops or cross-tie legs. So, this one, kailangan improved confinement sila. Ito, ina-allow to for very small size of column or, for example, bungalow house na hindi masyadong inaano yung loads, wala masyadong loads. So, this pinapayagan, although permitted, but hindi dinidiscourage because the confinement effectiveness is mababa. So, ngayon, once the transverse reinforcement has been selected in accordance with the seismic detailing, so the shear strength of the column needs to be checked. So, di ba napansin nyo, mayroon na lahat na as required for shear. So, another case yun yung mga may Vn equals Vs plus Vc, di ba? May ganon. So, another topic yon for column reinforcement. But this one is requirement for seismic detailing or to be ductile or based on NSCP section 418. Earthquake resistance for structures. So, in summary, so ito yung summary natin. So, nakakita dito sa picture na to, yung length ng LO shall be greater than or equal by the following. So, HC1, HC2, so yung clear span, 1/6 ng clear span, or 18 inches or 460 mm. So, yung tension lap splices is within the center half of the member length. Then, the spacing S1 within the confinement tie zone is the minimum of HC1 over 4 and HC2 over 4. Yung least dimension over 4. Yung shall be less than or equal to 6 dB or 6 times smallest diameter of longitudinal bars. The SO required, this one is the SO required, and as required for shear. Then, yung S2 naman is 6 dB, shall be less than or equal to 6 dB, 6 inches or 150 mm, and as required for shear. So, yung S0 is 4 plus 14 minus HX all over 3 in inches, or 100 minus, this is plus, sorry. So, this is plus. 100 plus 350 minus HX all over 3 shall be greater than or equal to 100 mm or less than or equal to 150 mm. Yung S0 natin. Then, along the confinement tie zone, dapat masatisfy yung table na to. So, condition 1, if the ultimate axial load is 0.3 FC prime AG and so dapat masatisfy yung dalawa, FC prime or F prime C is less than or equal to 70 megapascal or 10,000 70 megapascal or 10,000 psi, So, ang gagamitin mo is A and B. So, compare mo si A and B. So, the maximum governs. So, ASH over SBC greater than or equal to 0.3 AG over ACH minus 1 multiplied by F prime C all over the Fy of that tensile reinforcement. So, tension reinforcement. So, or ASH over SBC, spacing yung S, greater than or equal to 0.09 of FC prime of compressive strength of concrete and the yielding strength of tension reinforcement. And if PU is greater than 0.3 of FC prime AG or so at least one masatisfy of compressive strength F prime C greater than 10,000 PSI or 70 megapascal, you need to choose between A, B, and C. So, kailangan mong gamitin si C na ASH over SBC greater than or equal to 0.2 times factor na KF and KN times ultimate axial load PU all over Fy ng tension reinforcement times area of concrete core. So, another is column hoop shall be configured with at least 3 hoops. So, dapat merong at least 3 hoop or cross-tie legs para yung confinement is normal or not low, diba? Then, meron siyang special provisions for case 1 if PU is greater than, is less than 0.3 FC prime AG or if PU is greater than 0.3 FC prime AG. So, ito na yung every corner, yung may at least 150 mm yung distance, dapat mayroong hoops na 90 degrees sa kabila. Then, center line to center line supported is 360. Kailangan alternate o pinapayagan na mag-alternate yung hoops dito sa case 1. Then, sa case 2 naman, dapat lahat ng hoops ay may lateral reinforcement. So, every longitudinal bars around the perimeter of the column core shall have at least, shall have a lateral support. So, yun. Then, the center-to-center line spacing of longitudinal bars na may support shall not exceed 8 inches. So, dapat hindi siya lumagpas ng 8 inches or 200 mm. So, yun lang. Thank you. And mabuhay ang Ininyerong Sibil ng Pilipinas. So, before we end, please, sana may natutunan kayo. And this is una sa mga column reinforcement natin, seismic detailing. So, susunod may mga seismic detailing pa. So, don't forget to like, comment, share, and subscribe. And thank you pala sa mga subscriber ko, first 100 plus subscribers. So, thank you and maraming salamat. Maraming salamat po. Kayo po ang nagbibigay ang lakas ng loob sa akin para mag-share ng knowledge in structural engineering. So, God bless and mabuhay po tayong lahat.